single backyard telescope observation forced some of the most powerful observatories on Earth into an immediate race against time because Saturn had started changing faster than anyone thought possible. In 1990, Saturn was supposed to be quiet. For decades, astronomers treated it as one of the solar system's most predictable giant planets. Its golden atmosphere moved in stable bands. Its weather systems evolved slowly. Nothing dramatic, nothing urgent. Certainly nothing capable of changing on a planetary scale overnight. Then a hobbyist named Stuart Wilber pointed his telescope upward and noticed something wrong. A tiny white scar had appeared in Saturn's northern hemisphere. And within hours, the clock started running. At first, the observation looked almost trivial. A bright patch no larger than a pinprick against the massive disk of Saturn. Amateur astronomers regularly logged unusual atmospheric details on Jupiter, sometimes even Mars. But Saturn was different. Its upper atmosphere was considered relatively calm compared to the chaos of other gas giants. The white patch should not have been there. But what made the situation dangerous was not the spot itself. It was what happened the next night. The white patch had grown. Not slightly. It had physically expanded enough that telescopes across North America immediately confirmed the same thing. Saturn's atmosphere was erupting in real time. Something deep inside the gas giant had broken through the upper cloud layers, forcing highly reflective ammonia crystals violently upward. A perfectly smooth golden world had begun developing a wound, and it was spreading. Within hours, professional observatories started canceling scheduled observation programs. Facilities that had been studying distant quasars, stellar measurements, and galaxy surveys were suddenly redirected toward Saturn, because nobody knew how long the event would last. And that was becoming a serious problem. The phenomenon had a name, although few living scientists had ever seen one. The Great White Spot. Massive atmospheric eruptions that appeared on Saturn roughly once every Saturnian year, about every 30 Earth years. The problem was simple. The last confirmed event had happened decades earlier. There was almost no modern high-resolution data. This storm represented an observation window science might not get again for another generation. And Saturn was changing by the hour. The white scar kept expanding. Every new image arriving from observatories revealed the same disturbing pattern. The storm front was moving laterally around the northern hemisphere at astonishing speed, driven by winds exceeding 1,000 miles per hour. This was no isolated weather disturbance. The entire atmosphere was reorganizing itself. The smooth golden planet astronomers thought they understood had become unstable. And the safest assumptions about Saturn were beginning to fail. At first, researchers believed they understood what they were seeing. Heat rising from Saturn's deep interior had likely punched upward through colder atmospheric layers. Convection currents had triggered a pressure release, similar to thunderstorms on Earth, only magnified thousands of times larger. It seemed manageable. A rare but understandable atmospheric event. Then new images arrived, and the safe explanation collapsed. The storm was accelerating. Instead of dispersing outward and weakening, the white eruption had begun wrapping horizontally around Saturn itself, stretching wider each day like an expanding fracture line across an entire planet. The same visual anchor kept returning. That bright white scar. Only now it was larger, longer, angrier. And it was forcing scientists to confront something worse. Their predictive models had failed. Because according to existing atmospheric simulations, Saturn should not have been able to transition this quickly from apparent equilibrium into a violent planetary-scale weather event. Not in days. Not this fast. The observatories kept watching. Because every hour lost meant permanent data loss. Unlike Earth hurricanes, there were no satellites stationed nearby. No continuous weather systems monitoring the atmosphere minute by minute. Every measurement had to be captured remotely, from millions of miles away, while the event remained visible. And the planet kept changing. By now, the storm system had stretched across a massive portion of Saturn's northern hemisphere. That white atmospheric scar was no longer a localized anomaly. It was becoming a ring of chaos. And now the story had become bigger than Saturn itself. Because planetary scientists had built decades of atmospheric theory around one dangerous assumption. Gas giants evolved slowly. Their deep atmospheric systems changed gradually over predictable cycles. Their enormous mass supposedly buffered sudden instability. Saturn was proving the opposite. A planet nearly 600 million miles away had shifted into violent atmospheric transformation so suddenly that billion-dollar scientific infrastructure had been caught reacting after a civilian observer noticed it first. Not predicting it. Not anticipating it. Reacting. Then came the final image. The Hubble Space Telescope captured the storm after it had fully wrapped around Saturn. The scar had completed the circle. A perfectly smooth, golden world now carried a bright white atmospheric band stretching around the entire planet. And suddenly, the opening observation looked different. That tiny bright patch Stuart Wilber saw through a backyard telescope had never been a small event. It was the first visible fracture in a planetary system science thought was stable. And the consequences reached far beyond one storm. Because Saturn had exposed a weakness in planetary science itself, the assumption that familiar worlds behave predictably. For decades, scientists believed giant planets changed slowly enough that observation schedules could wait. Saturn proved waiting was the mistake. An entire world transformed faster than the institutions built to study it. And the first warning did not come from billion-dollar observatories. It came from one amateur with a telescope. Saturn was never calm. We were simply watching too late.